Hello guys, welcome back to my new video. In this video we have starting a new chapter, physics new chapter, which is chapter number 17, introduction to electronics. So what is introduction to electronics? So let's start. So what is electronics? So electronic is a branch of applied physics. You can say it's a applied branch of applied physics, which deals with the study of, you can say, with the study of flow of charges, in which we study about flow of we study about flow of charges which are in our control, which are controlled controlled by us. So in electronics is a branch of applied physics in which we study about the flow of charges which are under control us, which means which we can control. So let's take an example. For example, for suppose this is a conductor metal we have, and this as we know, the conductor have a free electrons. Okay, when I am connecting it with a device, this is a positive and this is a negative. So when I am connecting the device, it will start flowing electrons. So in this we are unable to control the electrons, means we will not allow this conductor to how much electrons should be passed, how much electrons should flow. We cannot control this is a conductor. And in electronics means flow of charge which are in our control. So in electronics we will always study about the semiconductor. So what are semiconductors? Like silicon is a semiconductor. So you can take also another examples. There are many examples. So here we are taking about the silicon example. So semiconductor is having a very short, in a very small amount of the free electrons. Means in semiconductor free electrons are there, but not in a very much amount which can flow. Semiconductor have less free electrons than conductor, but more than insulator. Semiconductor have more free electron than insulator, but less than conductor. So when we are giving a temperature, to a semiconductor, the more free electrons are released. More free electrons are released. Okay. When we are giving high temperature, more electrons are released, more free electrons are released. When we are decreasing temperature, when temperature is decreased, so again these electrons are binded together, or become in a one specific place. These are not then a free electrons. So when we are giving a heat, then these are the free electrons. When we are not giving the heat, these are not the free electrons. Like that way, when we giving the temperature, so these electrons are the become the free electrons. So means this are in our control. We want if we want to means if we want to allow if we allow to the flow of electrons, so we can give a temperature. If we don't want to allow, we will not give a temperature. Okay. So semiconductor example we have taken here silicon. The semiconductor have silicon and many more examples. And its conductor we have taken here metal. And now we will discuss about the types of electronics, as we are having in our book two type. So we are having two types of electronics: analog and digital. What is analog and what is digital? So firstly we are taking analog. So analog is a type of electronics in which gives a continuously changing, which is giving a continuously changing. Means, for example, if we have a daytime example, if in a daytime temperature is increased, increasing, decreasing, means it's not a giving a specific point, exact point. What's the exact temperature right now? So it's continuously changing. Sometimes means just sometimes temperature is 20 centigrade, 20.5 centigrade, 20.1 centigrade. Means in analog it's not a accurate value, we are not getting an accurate value, but in the digital we are getting an accurate. Means analog is less accurate than digital, and digital is more accurate than the analog. So analog is a continuously changing. Okay, so in analog electronics, it's the type of analog electronics. So in analog electronics, it's continuously changing. What is changing? It's not changing the temperature point. In this, it's changing signals. Means signals in electronics we are having, the signals are flowing. Okay, signal means electron. So electron are not flowing in a specific, we can say, a value. It's not means it's not flowing in a specific value. It is again and again changing, continuously changing. So that is called the analog. And while coming on the digital, so in digital, this is a continuously changing. This is a discrete, means it's not changing continuously. It is a specific amount. It is a specific, means a particular value. For example, in taking same example, daytime temperature is 20, then it becomes 30. So it's giving an exact particular, we can say, value, giving a particular value. It's not changing again and again. So that is called a digital. And digital is more accurate than, as we discussed, it is more accurate than the analog. It's more accurate in analog. We can take example in the example of analog, we can say. So taking example of analog electronics, so example we have, the example of analog electronic we have is speakers. We can take an example as a sound speakers, mics. These are the example of analog uh, electronics. So analog electronics is how these are, means a sound is, means this is continuously giving a change in sound. The signals are again changing. It is changing, means sound, the signals of the sound which are flowing are continuously changing. It's not in a specific, we can say, it's not a particular signals, particular value, but it's a changing, continuously changing. As an example in the digital, so in digital we have example of laptops, tabs. These are the digital, we can say, digital electronic devices which are more accurate than the speakers. So other point which I will be including, that analog have a, we can say, consistive quantities. It have a consistive quantities consistive quantity, and it have a digital quantities. So that is all about today. Hope you will enjoy this lecture, and see you in the next video.